I'm Campbell Harvey, professor at Duke University, and I'm moderating a session today on Ethereum Overflow. And we've got two excellent papers. The idea is that each presenter will go for 30 minutes, and then we'll have 15 minutes reserved for questions. And please use the Q&A function to put your questions into the system. So let's actually get started. It's great that we've got Ankit here from Frontier Research, and he's going to start. To me, this is, as a finance academic, incredibly interesting. The rate of change just over the past 2 years in this space is remarkable. And indeed, it's difficult to keep up. And part of what's happening today is to bring people up to speed in terms of what the latest issues are in terms of this market. So, Ankit, can you begin, please?
Am I audible?
That's good.
Does this full screen look okay? Perfect. Hello, everyone. Thanks a lot for inviting me. Thanks a lot for taking time to listen to my talk. I'm Ankit. I work as a research lead at Frontier. Frontier is a research organization that looks at the transaction supply chain. We look at it more from not necessarily from an academic point of view, but more from an industry point of view of how things are evolving technically and how different players in the system are playing the game practically. And so this presentation is more about how the whole decentralized networks order flow landscape has evolved over time in the last 16 years. And we will look at different eras in its timeline. A little bit background about myself. I was in academia almost like 7-8 years ago. I did a PhD. I was an aerospace engineer. I found crypto, fell down the rabbit hole, never came back, and I've been here since. And so this is I do know a bit about academia. So what I try to do at Frontier is even if there is a lot of chaos and degeneracy in this industry, I try to distill it into definitions and some sort of clear boundaries of how different players are acting and what are their core properties. And so this is what I want to give with this talk. This is more like a historical view of what has been happening, what are the key problems at each era people were trying to solve, and what were the emergent properties and difficulties due to these basic assumptions. So let's go. So this is split into 4 main sections. The first one is Bitcoin era, starts from 2008. We look at what Bitcoin was trying to do, what was its transaction supply landscape looking like. Then we look at Ethereum era, starts at 2014. It evolved into, it tried to prove something about it being a world computer. And because it was a world computer, it was quite successful. It had its own problems that was defined as atomic MEV in 2019. And then more recently, it transitioned into what we call as signal MEV, because there was so much activity happening on chain, more sophisticated parties started coming in. And so we'll look at how that looks like. And then more recently, we are in our opinion in the cross-chain era where it's not one single blockchain anymore, there are multiple blockchains, and just because things are cross-chain, it opens up two sets of issues. So let's look at each and every era. And so the Bitcoin era started from 2008. It started from this white paper published by Satoshi Nakamoto. We do not know who this entity is, but they just released, I think one of the motivations was this bailout at 2008. And they just released a white paper, they released a code base, and the core idea or the core intention of doing something like this was just showing the utility of a decentralized ledger. And what do we mean by a decentralized ledger? at the end of the day, what Bitcoin is, it's just a state machine that updates over time. And we call it decentralized because there is no single entity that is responsible for updating the state. And so every 15 minutes or every 10 to 15 minutes in Bitcoin, there is a random entity that is chosen, which gets the responsibility to update the state. And users create these transactions that saying that we want to update the state that we control in some way, shape, or form. That depends whether that transaction is valid or not, depends on the state transition logic that is encoded in the Bitcoin blockchain. And then this decentralized entity that gets chosen randomly, we'll not get into details of how that is chosen, why that is chosen. That is a different rabbit hole altogether. But that this decentralized entity gets to choose, pick and choose from the list of transactions, the transaction that they want to choose and how to update the ledger. And so what does this state transition logic look like? The state transition logic is, at the end of the day, just a ledger. It's a set of account numbers and then the balances that these accounts have. And then users issue transactions which say that, okay, they would basically issue a transaction saying, okay, I want to send 1 Bitcoin from my address A to another address B. And then the Bitcoin ledger basically verifies if the transaction is valid, if user A has 1 Bitcoin or not. And if it does, it takes 1 Bitcoin from user A's balance and then includes the user's B balance. And so this is the only thing that Bitcoin was supposed to do. This was the only state transition logic that was encoded in Bitcoin. And the core utility of Bitcoin was that we want to prove that this type of decentralized selection of state update actor is possible, feasible. There is some utility, and let's just show it to the world. And so this is what it did. This is what the transactions. This is what the order flow looks like. And so the users who have some account on the Bitcoin ledger, on the Bitcoin blockchain, generate this transfer transaction that we saw. And then they use their wallet to sign the transaction. And then they sign this transaction and send it to the public mempool. Because there is no set entity, they cannot send it to an a priori endpoint privately. They have to send this transaction to a public mempool. Everyone or any actor next selected to update the Bitcoin's ledger's blockchain can select from this transaction free floating set of transactions and update the state of the Bitcoin blockchain. So that is how the Bitcoin blockchain was being updated over time. We see that these three proposers, this is the old proposer or the old validator, it's called, or miner, it's called in the Bitcoin world, who had the possibility to update the state. Then there's a new proposer at this time, and then there will be a future proposer. And so this is how the blockchain evolves. Is because this is a decentralized system, you need some way to incentivize the proposers to do the work for you to include your transactions in the Bitcoin ledger. And what happens is the users have to set some transaction fee on top of it. And so proposers won't do work for you for free. So users have to attach some value on top of their transaction. There is some market around it. And so basically in the Bitcoin blockchain, proposers, what they do is they have some limit of transactions that they can include. They select, let's just say there are 10 transactions they can include. They select the top 10 transactions that are paying them the most. They pick them and then they include them in the ledger. So this is how the blockchain evolves over time. The main reason why I'm telling about this is even in Bitcoin, there is some extractable value, EV, what people call it. And this is a property of the decentralized system itself. If you were interacting with a centralized system, you might not need to pay fee. You would just send it to the centralized database and they will include you. But they're getting value from some other way. And so every transaction needs some value on top of it to get included in the blockchain. So yeah, this was the Bitcoin era. What Bitcoin tried to prove was there is some utility in the decentralized network. We have seen the current price of Bitcoin, and the experiment has sort of succeeded. And so globally, people trust this network globally. People think that they can transfer a lot of value around it, and so this experiment has sort of succeeded. And so, any questions for me for now? Okay. So, what happened next? So then there was the Ethereum era. So Ethereum came around in 2014. There was a white paper published by Vitalik. And basically what they said was, okay, Bitcoin is a state machine. The state machine has only one state transition logic, which is transfer value from one account. What we want to do is create a world computer where anyone can do anything. So instead of the state machine deciding what would be the state transaction logic, they let individual accounts also hold some code and some state. And so what you can do now in Ethereum, in the Ethereum blockchain, is you can deploy things called smart contracts. And what these smart contracts are, they are your own version, which you can encode. You can do whatever. You can write. You can create your own copy of the blockchain. You can create your own copy of ledger. These are called tokens. If once these tokens emerged, people created something called decentralized exchanges, which decided some way to transact, some way to convert from one token to another. Once tokens were also there, people also created lending markets. People created NFTs. There's just an explosion of innovation enabled by this world computer platform. Basically, a Cambrian explosion of different type of experiments. A lot of them failed. Some of them succeeded, and there are whole new billion-dollar industries on top of these experiments. But the only difference was you could encode any type of function on top of it. And so you can do you can encode tokens similar to just like people transfer ETH in the Ethereum blockchain. They can create their own token. They can create their own equity for whatever they're doing. And so what that converted into was in 2017, 2018, there was this ICO boom. Projects were raising funds like crazy. There were 100 projects similar to IPOs. They were called ICOs, initial coin offerings. There's 99.9% of that were vaporware. Some had actual utility. Some had a genuine team behind it. A lot of team did not, but still people were putting money into it. It just showed how much like there was an interest around it. The EOS is one of the blockchains that raised almost $4 billion during the ICO phase. In total, I think $13 billion were raised. And as soon as the tokens were launched, because there were these decentralized exchanges, you instantly had a price for them. So even if these things were not tradable in centralized exchanges, things like Binance, Coinbase, which had a very lengthy process for whitelisting tokens, as soon as you have a transaction, as soon as you have a token, you can send a transaction to a decentralized exchange and start and get a price for it. And so there were a bunch of decentralized exchanges that emerged. But the transaction supply at Ethereum was very much similar. So supply chain between Ethereum and Bitcoin did not change at all. Even though there was this unlock of encodability, the way transactions were moving from the user did not change at all. Users are generating transactions. They're sending them to the public mempool, and then the proposer was selecting transactions based on some algorithm. In the initial days, it was just the highest fees that I'm getting. But people soon realized that users are leaving more value on the table than they intended to leave. And so this was what was called as atomic MEV. So let's look at this example. Suppose there are three exchanges: Binance, Uniswap, and SushiSwap. All have the same price or around the same price in the initial state. A user comes in and basically sends a transaction in the public mempool. People can publicly see that it would move the price on Uniswap compared to the other two. And so what sophisticated actors can do is now they can instantly, just behind this transaction, they can instantaneously capture some value by bringing the decentralized exchanges back in equilibrium. And so the user only wanted to pay their fees, their transaction fees to get included, but they were leaving this arbitrage value on the table for a sophisticated actor to come in and capture. And so one more point to note, extraction is riskless and it's almost instantaneous, and that is why it is called atomic. There are even smart contracts called or functionalities called flash loans, where what you can do is you can basically take money from a pool of liquidity, do this arbitrage, and that liquidity only if you make profit. So because it was instantaneous in the same transaction, T was basically zero in this flash loan, in this pulling liquidity out of the smart contract, and this was all defined by the blockchain. There was almost no risk. It was purely instantaneous, pure profit that you could have extracted from doing something like atomic MEV at that time. So what happened was in 2019, there's this seminal paper called Flashbots 2.0, which showed what was happening on the Ethereum blockchain. And they basically said that there is like a 15-second time delta between two blocks. And so if a user sends their transaction, this is just one example. If a user sends their transaction, there is a race that goes on between these sophisticated actors. Now be the next transaction just behind this user's transaction so that they can capture the arbitrage value. And so this is just what two different actors are bidding to basically capture that arbitrage value, and one of the actor wins. There's the link to the paper. You can find more data at this website. But almost for 2 years, from 2020 to like I think around 2022, at 2022 there's a merge in which and in that time period, almost $675 million of value was extracted from users without their permission by doing atomic MEV. This is riskless, instantaneous. This is pure profit. Almost no barriers to entry. And so basically that old transaction supply chain that was there since the Bitcoin time evolved, where there was a new entity in between called the searchers, between the public mempool and the proposer, which was doing this, which was trying to figure out how much value I can extract from the transaction that is publicly available in the mempool, and how to order the transactions. And this sophisticated actor was called a searcher. And basically, the proposer is in the best position to extract the most value, because the proposer is deciding how to reorder the blocks, how to order the transactions in the blocks. And so the proposer was the only thing that the proposer was doing is basically outsourcing this work to the searcher. There were a lot of searchers because there was almost no barrier to entry. There's no liquidity cost. You can just borrow flash loans. There was a lot of competition. Proposers were getting like 95 to 99% of the value, while searchers were keeping very minimal. And one more important thing to note over here is to capture atomic MEV, all the information that you need is in this system. Like, you don't need any information outside of the system to basically capture atomic MEV. Yeah, so in the Ethereum era till 2022, I think what happened was Ethereum proved itself to be the world computer, or there is some utility in smart contracts and the 3-4 different streams of smart contract application that turned up. And just because of their success, because of the amount of value that users were leaving implicitly on the table, this new entity called Searcher emerged, which was able to extract almost $675 million of value in the 2 years after the ICO boom. Any questions till now?
Not right now. You can continue.
Everyone is understanding everything. Okay, so what happened after that? So after that, what we call as signal MEV. And because of the amount of order flow or amount of value that was flowing through the system, new, more sophisticated actors started coming in. These were not prop shops anymore of 1-2 people who were just trying to extract alpha from the public blockchain. Now people emerged where they started extracting signal MEV. And so what is signal MEV? Signal MEV is when you need information outside of the blockchain system, outside of the transaction supply chain, to extract value from the system. And we'll show later on that this way is more profitable, although it has. But you need information outside the system to capture value. And control of validator or control of proposer is not necessary to capture value. Only the ability to act on a signal is required. And so if you look at the same example, you have these 3 exchanges which are in equilibrium state. A user comes in, initiates some order which moves price of one exchange away, and then a sophisticated entity comes in. And because they have exposure to Binance, which is not in the blockchain ecosystem, but Binance has higher liquidity, it has cheaper hedging rates, they can capture more value. This is called as a CFI DeFi arb, centralized exchange, centralized finance and decentralized finance arbitrage. And this was different than the atomic MEV. There are many transactions, many types of transactions, and each type of transaction has their own distribution between EV atomic / EV ordering and EV signal. So if you are swapping coins on decentralized exchange, you might have similar value of EV signal, EV ordering. If there is a hack transaction, so there's a transaction which is hacking some protocol, if you just know that there's a transaction like this, then you can short that token on any venue and you can extract a lot of value. So it has a high number of EV signal. Only the information that this transaction is coming in and going to be settled on chain is required. You don't even need to bring that transaction on chain. You can just short it and just trust that the transaction will land on the blockchain sometime and extract value. And one more thing is market makers have negative EV signal. And so if you try to, people who work in traditional finance know this, like this is also called as toxic order flow. And so market makers have some knowledge of what the future price would look like. And so you should generally not trade. You should not be on the other side of the market maker. And so these are different distributions of how these 2 types of EV is split per depending on the type of transaction. EV atomic is in my opinion, due to decentralized nature of blockchains. And EV signal is as old as markets. Like there was a very old paper called, I think, The New Game in Town. Oh, sorry, The Only Game in Town. I think 1960s or 70s, which basically said that capturing signal is the only game in town. So let's just see how EV signal is more profitable. Each arbitrage has 2 legs. One is the revenue leg where you make money, and second is hedge leg. Because liquidity is low on decentralized exchanges, you need to spend a lot more money on the hedge side, and you cannot make a lot of money on the revenue. Whereas on decentralized exchanges, because you also have more sophisticated products like futures or options and a lot other stuff, the price of hedging is much lower, and so you can make much more money on the revenue side. It does expose you to risk, so you would need a lot of capital to actually execute something like this. You cannot do it atomically. So there is platform risk where you're exposing yourself to Binance. There's also time risk where you're holding these tokens as your inventory till you can settle off across the venues. But in general, this is more profitable. So what happened? So this is data from 2023, Q1 2023. We did this analysis with Jump and another decentralized exchange. We basically plot how much revenue entities are making between atomic and CFI DeFi arbitrage. And I think this was like a very significant event, and that's why a lot of money was made in atomic side at this date. But generally, CeFi DeFi has more revenue compared to atomic arbitrage, and also because there is low barrier to entry. Uh, any searcher can spin up. They don't need capital. They just need code that is deployed on chain. Validators get most of the value back from whatever revenue this arbitrage is generating. Whereas in CeFi DeFi, the searchers can take much more revenue for themselves because there is some risk involved. There is some capital requirement, and so it's a different game altogether. Note that these numbers are not accurate. We took some markouts. I don't remember exactly, but these numbers are depending on those markouts. The actual numbers may vary, but these are very much in line. Another thing that we saw was whether an arbitrage happens atomically or statistically or CeFi DeFi wise heavily depends on where the price discovery is happening and what type of token that is. And so if it is a new token that is not listed on centralized exchanges, or if it has very low liquidity on centralized exchanges, then generally the method of value extraction is atomic. Whereas if it is a token which has very high liquidity, is available on multiple exchanges, then the venue of or the method of extraction is CeFi DeFi. And so how extraction happens heavily depends on where is price discovery happening. If the price discovery is happening on Binance, then uh, searchers basically think that the price of Binance is their set price. Eventually, all the exchanges will tend towards that price. That is the venue of arbitrage between decentralized exchanges and Binance. And if the venue of price discovery are things like Uniswap or things like other L2s, because the token is only listed there, or because the token does not have enough liquidity on centralized exchanges, then searchers think that all the other exchanges will eventually tend to the price on this venue, and that becomes a source venue of the arbitrage.
So we have 5 minutes left.
Okay, thank you. Okay, so what we saw over here is because of the amount of money that was flowing through, or amount of EV that was being exposed, more sophisticated actors came in. They brought their own capital, they brought their own risk hedging mechanisms, and they were able to extract more value compared to atomic. And now we are at a new era. I think this is just the start of this era, and we'll let it play out for a few years to have more concrete theories on where it is going. But so what's happening with the cross-chain era? Blockchain, because there was so much activity happening on blockchains, whenever there's a surge in activity, the actual transaction fees to include a transaction on chain go skyrockets. Sometimes users have to pay $200, $300, $500 on Ethereum mainnet to get their transaction on chain, and it just becomes a traffic jam. And so because there's so many applications transactions, it becomes a traffic jam. I think 2-3 years ago, the Ethereum network decided that to solve this, we would have multiple lanes. We would have multiple chains called rollups, and this is what the future will look like. We are at the stage where there are a lot of chains now. New chains are popping every 2-3 days, but there are some UX issues, and we'll talk about that. So what does a rollup mean? A rollup is basically just you have an Ethereum state machine, which looks like this. You have another rollup state machine, which looks like this. And what the rollup is doing is it is compressing all the transactions there are multiple ways of compression. It is compressing all the transactions into one single transaction and committing it into the base chain, which is Ethereum. And so just by doing this compression, you can batch a lot of transactions which are happening in L2s or rollups into the Ethereum mainnet. And this is how Ethereum wants to scale to satisfy the infinite appetite of block space for applications. What it has resulted in, though, is a very bad UX. If you try to use a wallet today, it's a very broken experience. Users' funds are spread up, and users take tens of minutes and tens of dollars to bridge funds from one venue to another. This is what a wallet looks like. 2-3 years ago, this was a much better UX experience. It is causing friction for user onboarding. Although this is a nice way to scale up the demand for blockchain, but this is causing people are moving away to more faster, more monolithic blockchains because of this. So we wrote a paper called the Cake Framework, which basically looks at the transaction supply that we saw before, but for a multi-chain, cross-chain world. And you have the same players, but there are a lot of them in a cross-chain world, and they're doing a lot of things. But if at the end of the day, they are in their own 4 categories. One is the application layer, which are the second is permission layer, which is how the user gives permission to some actor to change their state of the account. The third is solver layer, which tries to basically find the best price. And then the fourth is the settlement layer, which are all these different blockchains. Each layer has its own core trade-offs. I won't go into too much detail on what all these different things do, but I'll just talk about some core trade-offs that each of this layer is trying to solve. The permission layer is trying to solve like this trade-off between UX and agency. Users want more agency, but if they want to improve UX, then they want to let it happen automatically in a cross-chain setting. Solvers, the job is to find the solvers trade-off is to find the optimal routing across different chains versus also ensuring that the user's intent is satisfied, the execution is guaranteed. And then the settlement layers trade-off is between low fees and execution speed of the transaction itself. Let's just come to conclusions. I think the cross-chain world is still very new. It's still evolving as we speak. So things have not. This is one way to think about it. To conclude, I think throughout its history, blockchain has shown different order flow dynamics. The dynamics have changed multiple times. Bitcoin wanted to prove the decentralized settlement layer thesis. Ethereum wanted to prove the world computer thesis. This caused atomic MEV, and that MEV. And now we are in the world of cross-chain, and it has its own problems. And that's it. Thank you.
Great. Thank you very much for the presentation. We do have a few questions, but to start things off, I'd like you to kind of clarify what you were saying regarding kind of overall liquidity and the kind of the correlation with the source of price discovery and how this kind of interplays with DEX. So there could be price discovery on DEX. So could you elaborate on this?
Is the question that can there be price discovery on DEX?
Yeah.
Or
yeah, and
okay.
and just how liquidity correlates with price discovery.
Got it. So there are two different things that determine price discovery. One is liquidity, and then the second is, are people actually using that venue to trade? And so when a token is very new, if the token is not launched on a centralized exchange, then the price discovery happens on a decentralized exchange. Even if it was on Ethereum, which has a 15-second block time, and so there is like the price just updates every 15 seconds. In newer chains, in newer rollups, which have sub-second finality, they have much faster block times, and so there is a faster chance for price discovery to happen even when compared to Binance. But even there, only till a period of time the token can show price discovery on the decentralized exchange. After some time, more sophisticated market makers come into the centralized exchange venue. Centralized exchange has a much cheaper cost of capital to determine to basically satisfy users' orders. It also has more sophisticated financial primitives like futures or options. And so the price discovery just tends to go there eventually. But there is this time period between not being listed on a centralized exchange and even after it is listed on a centralized exchange, although the time period is very small, but price discovery does tend to happen on decentralized exchanges. And one way to basically, so we cannot, so the high liquidity, low liquidity is also in this chart to just plot, differentiate between different tokens. And so we cannot, so if I come back to my initial point, which is the two ways in which price discovery determine liquidity on a venue, and if people are using that venue or not, we cannot figure out if how many people are using that venue or not. And so we just used one of that information, which is the token liquid or not, to make this graph.
Okay, thank you. So there's a question in the Q&A that I'll read, but let me also say that those of you online, if you raise your hand, you can ask a question. I'll just unmute you. So that's a possibility also. But the question in the Q&A is from Melis. It says, what is your method to identify which trades are CFI to DeFi and to measure the EV when parts of the legs are not on chain?
That's a good question. So there are a bunch of heuristics that we developed to figure out if a transaction is CFI, DeFi or not. So let's just look at how prices are updated on chain. So if we only talk about Ethereum, this is only for Ethereum, this chart. So if we only talk about Ethereum, the price update on the Ethereum blockchain happens every 15 seconds. And in that 15 seconds, the price on Ethereum is stable, but it is moving on Binance. And so at the end of that 15 seconds, there is some delta between the price on Binance and the price on Ethereum. And one way to capture that arbitrage is, or the only way to capture that arbitrage is if you are the first transaction of the next block that can reduce the delta. And so one heuristic is that the first transaction that is touching a pool. The second is these CFI DeFi traders also use very sophisticated methods to reduce the amount of blockchain fees that they are paying to the validator. So they do a lot of like optimizations in the way they pay the fees to the validator, which a normal retail user won't do. The retail user would just send. They won't route it through multiple smart contract venues to reduce the price to capture liquidity and all that. So we also look at that. And then just for operational purposes, a lot of CFI DeFi traders just use one address to execute that. So we had a list of like 20 addresses that were just doing these CFI DeFi trades. And we just looked at all these three heuristics. And for calculating the EV, what we did was we looked at the block time. And so block time is public. And we just looked at the price on Binance at that block time. Obviously, this is not exact. The CFI DeFi player or trader could have executed it at some other markout, but this was just an assumption that we took. Which is why if you see over here, sometimes the CFI DeFi players are paying way more than what they're making, because the markout might be incorrect in our case. But we think on an average it matches out.
Okay. Are there any other questions? And again, you can raise your hand if you want to ask a question. Okay, I've got another one in the Q&A. I'll read it. Can you please clarify what is the source for market makers' inside information? Question mark. Or in general, what drives the short-term price movements?
Okay, so just to clarify, the market makers don't have any inside information. Maybe I was not clear enough in earlier slides. This information is still public. Everyone can see it. Everyone can see the price on Binance, but the blockchain cannot see this information. So this is what I mean by the information is outside of the blockchain system. And so if you look at this transaction supply chain, there no way on this transaction supply chain is the price on Binance available. And so if you were an actor that was just trying to play this game atomically, you would not be able to extract the value by just relying on all the information that is available in these four entities. You need to somehow query Binance, hedge on Binance, and then take the risk of doing the trade on the blockchain to capture value. And the second was what drives the short-term price movements? Just market forces. As I explained, like Ethereum has 15-second block time. The prices become stale in 15 seconds. And in Binance, these are millisecond block times. And so the price on Binance has moved. See, there's an arbitrage opportunity.
Okay, great. Well, we are like almost exactly on time. So thank you very much for the presentation. And let's move to number 2, which is an empirical study of the Ethereum Overflow landscape. And Danning, please take it away.
Thank you.
Thank you. And here is my presentation about Overflow landscape, which I guess I'll do a quick intro. I'm Danning from Flashbots. I'm a data scientist, been working in crypto, specifically Ethereum ecosystem for a few years, and mostly focusing on looking at DEX trading data and recently MEV data. And presentation, thanks Ankit, because it helps lay the foundation of the context of what is MEV and what is the order flow we're talking about. And here, after the history class, I'm zooming into the Ethereum vertical specifically, and more granularly about like all the applications extracting the order flow MEV value, or like who are trying to acquire the order flow for their value, etc. I have a subtitle for this, which is PFOF is happening everywhere on Ethereum. You see I had that emoji of like, not great there, because supposedly, Ethereum and DeFi, its initial attempt away from, the traditional finance and PFOF way of, making, exchange happen. So yeah, here my agenda is I want to explain or answer these questions basically. What is order flow when we talk about it on a blockchain? What's the definition of them? And what are the types of, and how much value does the order flow contain? Or like, does each type of order flow contain? They might have value that differs or varies. And what are the forms of order flow auction happening on Ethereum? There's multiple names for it. Like you can call it order flow auction, or it's basically a payment for order flow in some implicit way. So yeah. So the first thing I want to show is to like lay a mental model of like what is order flow. So here is basically a life cycle of like if you are a user, you're interacting with blockchain or Ethereum particularly. How does the whole process look like? We kind of call it the MEV supply chain, basically from the left to the right. When users starting to interact with any front end or application, or like some people call it DApp because decentralized application, but really the front end is, hosted in off-chain, a centralized backend of Uniswap or 1inch or 0x. So yeah, and then they interact with the application. The application basically is quoting. Example, if you're trying to make a trade, they're gonna do the trading, quoting and routing off-chain. Like so, there's still some piece of software that's running and checking the on-chain state of different liquidity pools and maybe even off-chain liquidities. And then they're going to quote you a price, user going to confirm in the front end, and then they're going to prepare you a call data. And then they're going to send it, and user going to confirm in wallet, and wallet is going to direct you to RPC, or you can set an RPC in your wallet. And that RPC is actually the entry point for the settlement layer. So from here, RPC sending it towards. So I'm presenting this for the context of like after the merge with the POS proof of stake stage with the PBS, which is proposer builder separation setup. So which is right now today what we're using on Ethereum. So the RPC, they're gonna broadcast the transaction either publicly or privately, depending on if it's a private mempool RPC or not. They're gonna broadcast it to a mempool. Some searchers gonna look at all transactions happening.
Danny,
Yes.
can you just clarify a little bit what RPC is?
Yeah. I actually don't know the full name of it, but basically it's a link where you send your transaction towards, and that's the entry point where you then, how to say, the entity to receive your transaction information, and they're going to broadcast it to a bunch of node, Ethereum node. And the Ethereum node receive it, they broadcast to all the other nodes. You form a mempool, if that makes sense. Yeah. So yeah, and so the searcher now is looking at the mempool because, as Ankit explained, when they see the transaction that's gonna make a price movement on DEX, they see the opportunity of arbitraging the price difference between different funnels. It could be like an atomic MEV, which is trying to do MEV, how to say, arbitraging between Uniswap and SwitchSwap to DEXs. It could be a CeFi DeFi op when they see the price is very off from Binance. And so then searcher going to send a bundle to builder, whose job is to pack different transactions or bundles into a block. And so they are now in the proof of stake stage, the person who is deciding or have the finality of how the transaction is going to be ordered. And after that, they are going to send it through a party called relay. I didn't highlight it here. But then basically the relay's job is to simulate the validation there and broadcast only the value and the block hash to validator. So validator today, they are basically just checking what is the blocks all these builders are making. And if you're a rational player, you will pick the one that with the highest value that's paying to you. And as a matter of fact, today, validators are getting the most of the MEV value. Yeah, so I highlighted some of the parties here as green because those are the parties that are having the control or ownership of the order flow and trying to extract values. And we won't go through details. Just to give you an idea of like the scale we're talking about. So first of all, defining order flow value, we are using basically the gas priority fee user paid and also the Coinbase transfer, or basically the value that user or a searcher is transferring towards the builder who can decide how to transfer towards the validator. It's called Coinbase transfer, could be confusing, but it's really just like a function in the code called Coinbase.transfer in the MEV boost setup. And this state charts is showing how daily, what's the amount of MEV and also gas fee. Altogether, I would call it order flow value look like. And a high level number is that 500 million is basically the first 1 year after the merge, the total value that was paid out to validator. And so basically, yeah, all these value, 500 million is paid out to validator. Here is a more detailed breakdown of like, what are the order flow type we're talking about and what are the MEV value they're carrying. So maybe we'll look at the chart on the right side first. It shows the gas share of different order flow type over time. This is a 1 month data. And so basically you will see the big chunk of the transaction that's taking up the block space, or basically, measured by gas usage, is the green part. The lighter one is the public transaction overall. That's not a very special like MEV or like front-end attributed swaps. So just any other random public transactions, for example, like a value transfer or transaction like for just like other validating, etc. The darker blue is a retail swap. So all the retail users who goes to a DEX swap front end, or maybe even swap within their wallets, this is how much transaction happening, taking up gas usage space. And then there's the next one is the bot swaps. And then there's like non-atomic arbitrage MEV, which you see is a very thin line of the red. But you can basically now look at on the left side, the MEV share value doesn't look like this compared to the gas share. You basically could see that like the 80% of most of the transaction, including the public flow, retail swap, are only making up to around like 40% total of MEV value. And the highest MEV value here we see actually are two special type of transaction. One is sandwiching MEV, which, a subset of atomic MEV. Telegram bot flow, which is a very novel new type of front ends where the degen traders who are trading the meme coins like Dogecoin or like Pepe coin or and they use the Telegram bots, which is very specialized on like helping to sniping the token launch of a long tail token, etc. So, and to summarize, to have an overview of like the items I want to talk about today is that there's different forms of order flow auctions happening today after we see all this order flow type and MEV value, and happens in a different layer of this infra. The first few would be like DEX application layer. There's RFQ system, which is request for quote. I'm sure like if you're familiar with traditional finance, RFQ is not a word that you never heard of. So DEX aggregators, they have the RFQ design and they work with market makers who are basically trading on the other side on Binance and Coinbase. They're also providing quotes for DEX swaps trades. The RFQ filler on Uniswap X particularly is basically another RFQ example. Hashflow is in a project that's specializing in basically working with all the market makers and as a middleware for smaller routing parties to have access towards market maker. Because working with market maker, you need to onboard them and like set up the whole infra. For a lot of the smaller team with limited resources, it's very hard to do. So Hashflow serves as a aggregator of the RFQ liquidity in the middle, and then provide the RFQ quotes for some other routing front end. Solver platform is a new one, came up recently in just the past year. The example would be Uniswap X, 1inch Fusion, CalSwap. And in the RPC layer, there's also order flow auction happening. We just call them OFAs, basically MEV share from Flashbots or MEV blocker from CalSwap as examples. Basically, they provide an RPC. And so, which is what user use to send their transaction info towards. And then from here, they actually expose that transaction information to a set of permissioned searcher. The searcher might insert a background transaction, which doesn't hurt users' transaction price because it's right after users' prices. So potentially these searchers with the information from all these user transactions can have a opportunity to do arbitrage and extract value and potentially refund back to user. So the OFA is designed to redistribute value back to user. And there's also order flow auction happening on the block building layer. For example, now block builders, as we mentioned, who are the one that's trying to pack together the transaction into a block and bid it towards the validator trying to compete to win the inclusion of the next block. They have a lot of like smart strategies now. For example, they noticed that as we saw earlier, the Telegram bot transaction has great value. They're trying to do exclusive deal saying, hey, if you want to land your transaction, why don't you send your transaction just to us exclusively, not other builder. In this case, we will have an extra edge to compete for the block, and maybe we can actually keep the value as profits for you and me together, right? And then we can split it. So that's exclusively order flow happening. There's also like a searcher who are very famous called Jared from Subway, who is having a deal with another big builder. There's another one called end of block auctioning. So basically, builder saying, hey, once I finalize my block that I want to submit, I can still let searchers to take a look, what's the liquidity distribution look like after this block, and they can potentially insert background arbitrage as, like adding value towards it. So yeah, so those are the examples that I summarized as all the PFOF or order flow auction happening, and we're gonna go through each of them. Let's go to the DEX application layer one first, which includes like RFQ system and solver models. So to lay the context, I want to like show quickly like how the DEX trading space has evolved from 2017 to today 2024. It started with very naive model where it's basically hosting an order book saying if a user wants to trade, just come to us, tell me what token A and token B and token A amount, token B amount you want to trade. We will check if there's any match. If there is, we will just settle that transaction almost like an OTC. And that's like very inefficient because it's very hard to like have a lot of transactions that's like wanting to trade on the same pair with the exact same sides, etc. And so Uniswap came out around 2018. They designed a model called AMM, so automatic market maker. So they say, why don't everyone just submit like add their liquidity into a pool, and we can use a constant function to regulate what's the price for these pair of assets look like. And so they kind of solved the issue of liquidity. And now, so if any retail user you want to trade, you just go to a Uniswap and say how much money, how much of token assets is in your pool, and I want to trade, and what's the price. And so that showed a boom of the DEX trading, and it was around DeFi summer. And after which, there is also like fork of Uniswap, etc. A lot of the liquidity of the same assets get segmented into, or fragmented into different pools. The idea comes up as in like, we should aggregate the liquidity. And so there is, on the third chart here, is the DEX aggregator. So they're like, now liquidity is like allocated across different places, including Uniswap, SushiSwap, different AMMs. There's also still limit order books that's having user transactions submitted there and waiting to be settled. There's also market maker who are professional, players. They are interested in providing quotes to match users' transaction. Why don't we just do aggregation across all of them and try to like give user a better price? And so the next movement came up after that was that, there's multiple aggregators then now come up. And people were like, the aggregation theory, aggregating the aggregators would probably be a better price than the aggregators. And that's why we came up with like aggregator. We also call them meta aggregator. So MetaMask swap, which is basically within the MetaMask wallet, is an example. They're calling multiple API from aggregators. And CowSwap started with this idea as well, but they took a step forward and say, we want to decentralize it or basically outsource it to a bunch of players. Why don't we just tell people what's the intent from the user that was requesting to trade and let different parties to decide like giving us the best price and they can do whatever. So then that developed into a thing called a solver model. Each person who is or entity, trying to provide a quote to win the competition is called a solver. Some platform call it a resolver, or Uniswap call it filler to fill the order. So yeah, these are the trends that we've been seeing how the space sophisticated. And just to give an idea of how the scale look like, you can kind of see the evolution happening in data as well, where basically the pink is DEX front ends, which is when Uniswap started. And then afterwards there's aggregators or basically whoever the front ends is calling an aggregator API. We call them aggregator integrators. And there is orange, which is when wallet saying, oh, user definitely prefer, simple UI and UX. They'll be like, why don't we just add a swap function within the wallet? And so you see wallet swaps. And then there's also solver model then came up, which is light blue, where people are saying, hey, we can do more aggregation and outsource it with the competition, which supposedly should make the price better. And the very recent pink here is the Telegram bots, which serves particularly degen trading needs. And some interesting detail is that when you look at different front ends by different attributes, so the left charts is showing different trade size on the left from very small to the right very big. You see different routing or basically DEX trading solution serves different sides. Telegram bots trades are always very small. Wallet swap is leaning towards smaller trades. DEX front end is leaning towards small, but also serves all range. Meta aggregator and solver model are basically serving for larger trades. Larger trades user naturally cares more about the price. They're more sensitive towards like a pricing kind of aspect. So they prefer, or I would say like they're more advanced and about the DEX trading space knowledge, and they would pick the solver or aggregators. On the right side, you see this is a segmentation by trading pair, by long tail, or if it's a pegged token, meaning there's no price discovery, or it's ETH BTC towards major token pair. You can basically see Telegram bots also only existing very long tail trading. So yeah. So I try to summarize all these different type of front ends to see what are the type of trading needs they serve today within DeFi. My conclusion would be that, so I kind of color coded them. The Telegram bots is yellow, and you see they're like very high frequency. It's almost like a bot kind of behavior, but very small trades. And then the pink is the DEX front ends, which means Uniswap or Curve or Balancer, SushiSwap. I cannot really cluster them into one bubble because Uniswap is just like such an outlier. They are the first mover. They have the distribution power. They are the one basically on the top, which is the circle themselves on the pink one. All the other DEX front ends, they actually kind of like spread out across different trade sites. This is because different AMM design today has a lot of diversity in terms of how they are designed to be optimized for larger trade or smaller trades. And then meta aggregator are around medium whale trades. And then the solver model are only basically seeing around bigger whale trades. And wallet swap, the gray one, is also very small retail trades. And you can see that within these quadrants, the black for DeFi is basically on the top right, which I think is basically high frequency and large trade needs is still not really served by DeFi, but happening on CeFi, Binance, and Coinbase. MEV bots for sure also is one example, but I wouldn't categorize it as like, the retail needs. But yeah. So here is a empirical study. Like this is a screenshot of like how does the Ethereum order flow look like distributed across different front ends. And I will quickly go through what this is telling us. On the left side is like different volume comparison across front ends. We can basically see Uniswap and 1inch are the number 2, the highest, and then CowSwap. 1inch is split across the website, default, and integrator, so it might not look obvious. And for different front ends, they may have different routing solution that they're routing towards. And for the routers, they sometimes also like settle it through market makers or solvers, etc. And the next layer is like when the RPC sending towards different mempool. So some of them goes to private and some of them go to public. It's kind of shocking that like half of the volume today is going through private mempool already on Ethereum DEX. Then there's like builder, etc. So just quickly, so the first order flow auction I want to explain would be RFQ. So RFQ means request for quote. We kind of also mentioned it already. Basically, when the user comes to a front end, the front end can basically ping not only the AMM pools, just check what's the price in this pool, but also can ping professional market maker A, B, C, or 1, 2, 3 saying, hey, what's your price for this trade? And then they can compare across AMM and market makers and say, oh, actually, RFQ had a much better price than AMM. We should give this to user, and user will have a higher, price in the end. So RFQ integration has been, growing. You can see by the number of color, which is different platform who has starting to integrate RFQ liquidity, and the number of color has been growing. The volume in total is down just because the overall trading markets has been down in the past 2 years, like in the bear markets. Another view to understand this is that when you see the Sankey diagram from the left, where the front end has the users, request traffic, and it goes to the router, you can kind of see in details like then which liquidity is sources. On the right side, you can kind of see basically, for example, 1inch router is routing mostly towards Uniswap V2 and V3 liquidity pool, but then there's also a big chunk here, SCP PMM. They are actually a market maker who are also, like providing quotes to this MetaMask swaps front end. So something interesting here is that they are actually getting smarter and smarter as well. So in the past, the market maker also only sits behind 1inch RFQ or 0x RFQ, which means there was a middle layer by the aggregator, and they provide quotes to the aggregator. But now they'll be like, why do I need this middle layer which may charge me fee? And if I remove that middle layer, I can talk to the front end who has order flow directly. And that's why you see here the SCP market maker just calls to MetaMask directly. With one less layer of fee, they actually can provide potentially better quotes. So that's RFQ. And so what is solver model? Basically, the idea is that now DEX aggregator, what we mentioned earlier is that they ping AMM, they ping market maker, they compare the price, and they give the user back, user confirm, send it to on-chain. But now the solver model will be slightly different, where the platform will only just ping a bunch of players who are the solvers that's gonna give the quotes to compete and check and see like what's the best price. It's somewhat an extra layer of aggregation. And for different solver, it's possible that they are integrated with AMM or market maker, or AMM and market maker, or only AMM, or they are a market maker themselves. So we see this happening as well. Started with CowSwap, and then 1inch Fusion started as well, and then Uniswap started from last summer, and the volume has been growing. And so a few things interesting here is we mentioned an interesting project called Hashflow, which is basically served as a middle layer for talking to the market maker and serving their quotes across different small routing parties. And you see this happening here in the CowSwap solver system. So on the left side, it's all the front-end traffic that's bringing users trade intent into CowSwap. CowSwap pings a bunch of solver, which is in the middle. You see PLM, propeller swap, barter, etc. And a lot of the solver, they ping hash flow, and hash flow then talk to a bunch of market maker on the liquidity side. So that's kind of interesting as well. You also observe the direct disintermediate integration here as well, where PLM, their volume basically fully almost all goes to SCP. That's just their name as a solver within the CowSwap system. They're basically the same person. So market maker can be a solver as well directly. Another example is 1inch fusion. So this chart, I included both the 1inch router and also the 1inch fusion. On the left side, you can see. And I would say the volume scale is that they're almost at par. And you can see after the 1inch fusion layer, there's solvers. And you also see this integration of like Resolver having their liquidity all going to Wintermute, who is a famous market maker as well in the DeFi space. So you would know Resolver is basically Wintermute. They're just like undercovering themselves under a name. And then this is the Uniswap solver model, which and also Uniswap classic router, which is universal router. And you can see clearly here that like Uniswap universal router is like basically only routing across V2 and V3 pool, while Uniswap X is basically all the RFQ parts that's going for the Uniswap users. So if we look further, if you look at all the different fillers who are winning the volume on Uniswap X, you can basically see it's quite centralized. Basically, a few colors, basically SCP, Flow Trader, Wintermute, and Tokalab, 4 market makers are basically providing more than 95%. So one conclusion to mention is that as we saw in the liquidity distribution chart earlier, the Sankeys, you see that different solver model, they are designed to serve or favor different liquidity type. For 1inch and CowSwap, a lot of the solver are smaller entity who are like checking the AMM liquidity and trying to win in their sophistication on routing, while Uniswap X really is just designed to integrate RFQ liquidities. So the next order flow auction I want to mention is in the RPC layer. We call them OFA overall, basically. So one thing to explain this would be these diagrams from Frontier. Actually, if you don't consider OFA, the MEV supply chain look like this: user, wallet, searcher, builder, validator. But if you introduce OFA in this flow, it's going to look like basically wallet is sending to a RPC, and basically they will allow a bunch of bidder or searcher to look at the transaction and arrange their MEV transaction and send it back as a bundle to builder. So that's how OFA actually is implemented. Another more detailed chart, but I guess I'll just skip it. You guys can check the slides afterwards. I would say OFA overall isn't that high in terms of adoption. MEV blocker would be the highest, OFA that's by adoption or by volume, and it's really around 5% of all the Ethereum transactions. So I want to quick zoom out about what we just mentioned, which, like to have an idea of like the whole picture of how DEX trading look like right now. So user will go to a front end, which could be a DEX aggregator, and they will probably have an RFQ system where they are checking the market maker's price to compare with the AMM price. And in the AMM liquidity as well, just one extra thing to mention, oftentimes, when the liquidity moved away from the real price or mid price or market price, which basically is centralized exchange price, there's arbitrage bots going to take away the bad liquidity, which, as Ankit already explained, they're called toxic flow. And then so go back to DEX users orders. So a RFQ order or AMM order then going to be sent towards a mempool. If you send into a public mempool, a lot of searchers are checking the orders. And for AMM orders, they're going to be able to extract the MEV value. And if you're sending to a private mempool, oftentimes there is like OFA searchers trying to background and like bundling your transaction. And then all these bundle goes to block builders. And what's interesting here or like concerning here is that all the red stuff here I highlighted: market maker, MEV searcher, ARB bots, OFA searcher, block builder. they're now basically all dominated by a few entities who are all market maker. So this meme is basically, like all these people with different name turns out to be the same party, and it's quite centralized, which is totally not the idea for DeFi. Yeah. On the block building layer, I want to just quickly mention a few other, how to say, expression of like order flow auction. One is exclusive order flow deal, one is end of block auction. So the order flow acquisition on builder layer is going higher and higher, and is also causing centralization force, which is quite concerning. So what matters for block building? When you want to build a block with as much value as possible, you want as much as order flow as possible. So you want to, ingest as more order flow you have. As a builder, this might mean you need to even like subsidize to get your block included. And so your market share looks really high in the chart. And so people now be like, if I want to land in my transaction quickly, I need to send to that builder. So that's kind of like a subsidy marketing strategy some builder even use. But also you want to talk to different people to like send their transaction flow to you. And more importantly, privately sending to you. Because if you have that value, other people don't have, then you potentially can keep some margin by yourself and maybe split it with your order flow provider. And the higher the value the order flow has, the better. So here are just some like principle for block building and why there are games and strategy being developed. And the order flow MEV value drives a lot of the order flow into the private mempool, as we explained earlier. So there's a lot of privatization happening right now. As you can see here on the right side, the gas share, or basically number of transaction or transaction, by block space usage looks like 80% by public transaction, 20% by private transaction. But then you can see basically on the left side, the MEV value of those transaction carry is like the flip. Basically, the private transaction, 20% of private transaction is carrying over like around 60% of MEV value across all the Ethereum MEV. And this drives the adoption of private mempool, basically. Right now, we are having like 15% of Ethereum transactions are going through private mempool. But this number, basically, if you look back, it has been growing pretty crazily. In the Q1 2023, we were seeing all the builders having around 5% or 3% of private transactions. And in Q3, you see this number is going up to 15%, and which is what we're seeing right now, roughly as well. And if you like draw the correlation of private order flow percentage and the winning rate of a block builder, it's like quite obvious, like the more transaction you have, the more likely you're gonna win the blocks. Highly correlated. And if we look at MEV value percentage by different front end again, you would notice that we mentioned Uniswap front end is like the biggest volume across DEX trading space, but their MEV value isn't really that high if you compare across all MEV value. The front end itself, the value really comes from the gas priority fee user pay. There isn't much more like extra like Coinbase transfer value attached to it. The other side of the coin, though, is that they do still play a big part. So if you look at all MEV value by transaction, that if they ever had a swap or not, which basically means if there's ever swap in Uniswap pool, which is the most dominant liquidity source today, 77% of the MEV value comes from a transaction with a Uniswap swap. So yeah, and if you look further into all those transactions with a swap, you can kind of also see a same distribution we saw earlier, where the orange are the one that without a swap, and then goes down will be atomic MEV sandwich with the highest MEV value, and then there's Telegram bots. So one thing we noticed is that if you examine all the order flow type by MEV value across the top 3 builders, you can see, for example, here in February 10th, there's a huge jump in Titan builders block, where Banana Gun router, which is a Telegram bot with the most MEV value, has jumped. And basically, it's confirmed the assumption by many people that they're having exclusive deal. And you can kind of see this like the black line, which is the cumulative profit of the builder, like jumped crazily like compared to all the other builders' profits. And the result is builder centralization. Today, the 3 builders we mentioned just now is making 95% of Ethereum blocks. And two of them are high frequency trading firm with CeFi, DeFi ARB transaction flow. This is quite concerning for Ethereum overall. Another thing we saw that's pretty smart and happened just recently is that if you examine all those builders block by the transactions position, so here x-axis is like from the first transaction in the block, 10 percentile, 20 percentile to the end of the block. You kind of see Titan and Async, who are two of the top builders. They have this purple value, which is atomic arbitrage MEV, that's only seen in the end of the block. Compared to Beaver, they don't really have it right now. Basically, what the builders are doing right now is saying, I packed my block and it looks like this. And if you're gonna land on chain, this will be how the liquidity distributions movement look like, the price movement will look like. And Searcher now, you can basically bid to see how much transaction value you can extract by adding a background. And I'll include your transaction in the end of my block, and we can maybe split the profits. So end of block auctioning happening as well as another one. I think I'm done with my slides. Yes, I'll check questions now.
Okay, great. Thank you very much, Danning. There's a bunch of questions that have to do with PFOF. So, and you actually put it at the beginning of your presentation. So I'd kind of like to lead off. So in traditional markets, it used to be that the retail investor got screwed. But then Robinhood came along and auctioned off effectively those orders. And those orders are very valuable because they are orders from investors that are not informed. So you want to trade against uninformed investors. You don't want to trade against hedge funds. So you mentioned the Telegram sort of swaps that are very popular. And I'm just wondering, is there an equivalent? Like today, the Robinhood traders get just a great deal. They're effectively rewarded for not having information. So is there any equivalent in terms of this space? And could you talk more about the Telegram traders?
Yeah, 100%. So I would say the closest example to the Robinhood example would be the RFQ system that's happening right now on DeFi. So basically, if we look at this flow chart again, right? So the user comes to the front end, and the front end, or basically the router or DEX aggregators, they're gonna ping the market maker, who are basically informed traders, are checking closely the Binance price, and they have the infra set up with potentially all the signals coming from different channels of like how the liquidity might move. They will then give a price towards the user. And that's exactly user is trading against the informed players, which is quite bad. And so market maker here is providing quotes to a user directly. Another part would be when the market maker player who are also inserting CeFi, DeFi ARB when they are handling the blocks. I think that's the two most obvious part that some part of the party are also making trades based on these DeFi information on the CeFi side. Of course, I think one vertical integration thing is that all these market makers, they are also MEV searcher and OFA searchers. Arbitrage bots are also another example of like informed traders, but the victim would be not the retail user, but the retail liquidity provider.
Okay, so let me try a different angle here. So, and this is related, I think, to Marius's question in the Q&A. So is there kind of any differentiation when it kind of goes to RFQ if it's coming from an uninformed trader like like the Telegram bot versus something else?
Yeah, so I just also checked Mario's question here. I'll go to that one first. So if the market maker is paying a Uniswap, they don't, Uniswap don't have a RFQ system standalone, but the Uniswap X platform, which is their solver platform, is basically serving the goal of introducing the market maker liquidity. So I think right now Uniswap X is not charging market makers, but in the near future, we can totally see they're starting to charging the market maker. For most of the other RFQ on DeFi right now, market maker do pay a fee for the flow they win. And the number is around like 5 bips for most of the major pairs, say, WETH towards USDC, and potentially a much lower, like 2 bips for stablecoin, which has much lower price discovery. So, and then could you also repeat your question again, please, Campbell?
Yeah, so the question is whether there's any differentiation in terms of where the order actually comes from. There certainly is a differentiation in traditional finance if the order is coming from Robinhood versus Goldman Sachs, because we just assume Goldman has got information.
So do you mean the fee comes from different front ends, like for example, for a Uniswap user or Telegram bots? Right.
When you go out for RFQ.
Okay. So first of all, RFQ only wouldn't really, has anything to do with Telegram bots today. And I think like RFQ fee only really differ in terms of like what's the trading assets are. Different different systems, they charge differently, but I don't think there's like very, like public number about how much they charge.
Yeah, I guess what I'm saying. So what I'm saying is it's coming from like an aggregator. So the aggregator is looking around, but I guess the key thing is there a differentiation between different sources of swaps? And I think your answer is no.
I don't think.
And that's a difference between this market and traditional markets.
I see. I saw Ankit also raised his hand, so maybe he has an answer for this too.
Yeah, I would say like there is a sort of implicit differentiation between retail and sophisticated traders. So if anyone is generating orders from the websites for these front ends, so if you are generating orders from Coinbase Wallet UI, MetaMask Swap UI, or even Uniswap UI, then instead of PFOF, where PFOF gives price improvement to the retail traders, they charge a 1% fee if you are using the UI. So it's reverse of PFOF basically what's happening. And I think mostly that is because people just want to trade these things. And so I think the market has not moved to a point in time where all these venues are trying to compete amongst themselves to get more retail order flow. And so I think it's a more evolution thing.
Yeah, that's helpful. There's a question by Anne, and I guess I'll read the key part of it. That in equities, we see a trade-off between PFOF and price improvement. Do you see a similar trade-off in Ethereum? In equities, investors can use a broker which does not receive PFOF. Is there a similar option in Ethereum?
Maybe I will try to like explain what I understand, how the front end is comparing and picking the order flow, like if it's using AMM or the PFOF way, the RFQ. So I think like most of the time, the front end is comparing that if the RFQ quotes were worse, but then they're gonna use the they're gonna submit the transaction for user, the price impact difference, how to say, the price improvement difference, it can cover the gas fee, then they will route it to the RFQ quotes a lot of time. That's one thing I observe. And the question. So I kind of see the trade-off between like, sometimes you're suffering a less good price, but you're, having a better UX because you don't need to submit your transactions. For in the solver model case, you basically just sign the signature and then they're going to submit for you.
Okay. So Marius has got something here. Also, I wonder how the RFQ market makers manage their inventory. With retail PFOF, wholesalers expect balanced order flow. Here, it seems less likely.
What does balanced order flow mean?
That it's not like 99% sell.
I see. I, I with retail PFOF, wholesale expect balance. I don't think it's gonna be 99% sale for DeFi.
Yeah.
Yeah.
So the idea, and Marius has clarified, if you've got kind of a balance, then there's a lot of cancellations, and that means that you don't have to carry a large inventory.
I see.
So so can you talk a little more about how this RFQ actually works in terms of the inventory aspect of it?
Right. So I think, well, that's a question of how market makers handling their inventory. On the CeFi side, I don't really know the alpha of how they're, like rebalancing here and there. But my understanding is basically when they're providing quotes here, they are making another, transaction on the opposite. Like if they're selling it here, and then they might capture a price difference on the say they're on the CeFi side. So that's why they also want to make sure right after the transaction is settled, they want to like trade on the CeFi side as soon as possible. I think sometimes there's some market maker, it's unsure if they're trading on DEX first and then settle on CeFi, or they're trading on CeFi and then they're providing a quote on DEX. Market maker hates the case when they're providing a quote and the quotes need to sit for 30 seconds. And the front end, the user is sitting on the trades until the very last second to confirm and submit a transaction, because that means they promised the trade for basically 30 seconds of time option. And that's considered also toxic flow for market maker. I'm still not sure if I am answering the question, because I think there is a knowledge gap about TradFi here from me, but.
Yeah, so, but Marius has clarified here. The reason I'm asking is that AMMs are designed to share risk pro rata among the liquidity providers. With RFQ, it's single traders absorbing a large amount of risk. So, that is a fundamental difference between like DeFi and kind of traditional finance.
I see.
Okay, we've got another question. I wonder who the RFQ market makers are. Are they from TradFi space and thus more active on centralized exchanges, or are they DeFi native players?
Yeah, this one I'm familiar. So the biggest market maker right now in the space is Wintermute, SCP, and a few other players like Autonomy, One Bitcoin. I believe most of them are DeFi native. For example, like SCP started as a MEV searching firm. They were trying to do arbitrage or atomic arbitrage across different pool, and expanded towards all these CeFi, DeFi arbitrage, etc. Wintermute, I believe they do have some like stock markets kind of business as well. For a time period, there were also a lot of TradFi big players comes in. For example, like Jane Street, and there was another one. Jump Trading as well was a big player, but they kind of faded away right after there's a lot of pressure from the SEC or regulation side. So yeah, there were definitely a lot of interests, but right now, whatever that's in the space are I would say more DeFi native ones.
Are there additional questions? And again, you can raise your hand if you want to raise your hand, and I can unmute. Anybody else? We are like just very close to the time that that we had actually advertised. So we're 2 minutes over. So I'm going to close the session right now. And I would like to thank Ankit and Danning for providing really interesting presentations, and thank everybody for attending.